Hello everybody. In our previous videos, you have studied about trigonometric ratios. In this lesson, you will be studying about some ways in which trigonometry is used in the life around you. In this lesson, we will see how trigonometry is used for finding the heights and distances of various objects without actually measuring them. So, welcome to the lesson. Let's look at this figure. In this figure, there's a student standing over here and looking at the top of the minar. This line is called the line of sight. The angle formed between the line of sight and the horizontal line is called the angle of elevation. The angle of elevation is above the horizontal line. So when you look up, the angle formed by the line of sight and above the horizontal line, that is called angle of elevation. Similarly, if you look at this figure, the girl observing a kite, this line is called the line of sight, and since the angle is above the horizontal level, it's called the angle of elevation. So we know what is an angle of elevation now. Let's look at what is the angle of depression. Now let's look at this figure. The girl sitting on the balcony is looking down at a flower pot placed on a stair of the temple. In this case, the line of sight is below the horizontal level. This line of sight is below the horizontal level. The angle so formed by the line of sight with the horizontal is called the angle of depression. So the angle of depression will be below the horizontal level with the line of sight. So we know what's an angle of elevation, which is above the horizontal level and the line of sight. Angle of depression is below the horizontal level and the line of sight. Now, based upon this information, let us try to solve some application problems. Let's try this. A tower stands vertically on the ground. From a point on the ground which is 15 meters away from the foot of the tower, the angle of elevation of the top of the tower is found to be 60 degrees. Find the height of the tower. So let us draw a simple diagram. The tower is AB. The point away from the foot of the tower is 15 meters, BC. And the angle of elevation ACB is going to be 60 degrees. We are required to find the height AB, which happens to be the height of the tower. From this triangle, which is a 90 degree triangle over here, from 60 degrees, can we label the sides of the triangle? This will be the opposite side. This will be the adjacent side. And of course, this is going to be the hypotenuse. Now, we are supposed to find the opposite. We know the adjacent. Which ratio can we use? Which trigonometric ratio can we use? Opposite over adjacent. Which ratio? Tan. Very good. So tan 60 degrees is equal to opposite, which is AB, over hypotenuse, which is BC. So tan 60 degrees is equal to AB over BC is 15. What is the trigonometric ratio of tan 60 degrees? What is the value? We have learnt it in the previous lessons. Tan 60 is √3. You need to remember these values. Tan 60 degrees is equal to √3. So √3 is equal to AB over 15. Cross multiply. AB is equal to 15 √3 meters. So the height of the tower is 15 √3 meters. This was a pretty simple problem. The only thing is represent the problem in the form of a diagram. label the sides of the triangle, figure out what side is given and what side you need to find out, and then choose the appropriate trigonometric ratio. Remember what is the value of that trigonometric ratio and then use it in solving the problem. Let's try another one. Let's try this. An electrician has to repair an electric fault on a pole of height 5 meter. So the height of the pole is 5 meter. She needs to reach a point 1.3 meter below the top of the pole to undertake the repair work. That means the total height of the pole AD is 5 meter. From here to here is 1.3 meter. She has to bring it down. So 5 meter minus 1.3 meter is going to be 3.7 meters. So we know BD now. So let's continue with our problem. What should be the length of the ladder that she should use, which, when inclined at an angle of 60 degrees to the horizontal, would enable her to reach the required position? Also, how far from the foot of the pole should she place the foot of the ladder? You may take root 3 as 1.73. So we know the total length AD is going to be 5 meters. AB, the ladder has to come down to 1.3 meters below the top of the pole. Therefore, BD, the height BD is going to be 5 minus 1.3, which is going to be 3.7 meters. Now this forms a triangle BDC. Now in triangle BDC, we are supposed to find the height of the ladder, the length of the ladder, which is BC, which happens to be the hypotenuse of the triangle BDC. From the 60-degree angle, this side is going to be the opposite, this is going to be the adjacent, and this is going to be the hypotenuse. Now we are supposed to find the hypotenuse. We know the opposite. Which ratio will you use? Opposite over hypotenuse. Which ratio? Sine. Great. So we can use sine 60 degrees is equal to opposite, which is 3.7, over hypotenuse, which we don't know, that's BC. How much is sine 60 degrees? What is the value? It's root 3 over 2. So I can write for sine 60 root 3 over 2 equal to 3.7 over BC. Cross multiply. BC is going to be equal to 3.7 times 2 over root 3. Simplify that. You can use root 3 as 1.73 as suggested in the question. Approximately you get 4.28 meters. So the length of the ladder has to be 4.28 meters. Now the question also asks us to find how far from the foot of the pole should she place the foot of the ladder. In other words, find the adjacent side. Now since we have to find the adjacent side, we know the opposite, we need to find the adjacent. Opposite over adjacent is what? Tan. Adjacent over opposite is cot. So can I use cot instead of tan? I can. You can use even tan trigonometric ratio also. So let's use cot. So cot 60 degrees is equal to adjacent over opposite. Adjacent is DC over opposite side, which is BD, that happens to be 3.7. But what is the value of cot 60? Remember that? If you don't, go back and review it. You need to know these values. Cot 60 is 1 over root 3 is equal to DC over 3.7. Therefore, DC is going to be equal to 3.7 over root 3, which happens to be 2.14 meters. So the distance over here from the foot of the ladder to the pole is 2.14 meters. So we figured out what was the length of the ladder. We also figured out the distance DC. Pretty easy. You need to know the values of these trigonometric ratios. Let's try this. An observer 1.5 meter tall is 28.5 meter away from a chimney. So the height of the observer is 1.5 meter. So this is 1.5 meter. Is 28.5 meters away from the chimney. So the distance over here, this distance is 28.5. The angle of elevation of the top of the chimney from her eyes is 45 degrees. What is the height of the chimney? The complete height of the chimney. So the height of the chimney is nothing but AB is equal to AE plus EB. And EB, this happens to be 1.5. So the whole issue now is to find AE. So AB is nothing but AE plus 1.5. So we need to figure out AE. We also know DE is 28.5. DE is 28.5 meters. So ADE forms a right angle triangle. Let's mark the sides of the triangle. From 45 degrees, AE happens to be the opposite side. DE happens to be the adjacent side. And this is the hypotenuse. So now let's figure out. We are supposed to find the opposite. We know the adjacent. Opposite over adjacent. Which trigonometric ratio? Tan. Great. So tan 45 degrees is equal to opposite, which is AE, divided by adjacent, which is DE, that happens to be 28.5. What is the value of tan 45? It's 1. Good. 1 is equal to AE over 28.5. Therefore, AE is going to be equal to 28.5. But that's not what the question is asking. The question is asking what is the height of the chimney. The height of the chimney is AE plus EB. So the height of the chimney AB complete is going to be 28.5 plus EB, which is 1.5. And that is going to be 30 meters. So don't make the mistake of telling that the height of the chimney is 28.5. No, we need to take into consideration the 1.5 meter also. So the height of the chimney is 30 meters. Great going. Very simple application problems using trigonometric ratios. You see how trigonometry is used in finding the heights of objects without actually measuring them. Let's try another one. Let's try this. From a point P on the ground, the angle of elevation of the top of a 10 meter tall building is 30 degrees. So from here to the top of the building, this angle is 30 degrees. And the height of the building is 10 meters. Okay. A flag is hoisted at the top of the building and the angle of elevation of the top of the flag staff from P is 45 degrees. So from here to the top of the flag staff, the angle of elevation is 45 degrees. This one, complete. find the length of the flag staff. So we need to find BD, only this much. And the distance of the building from the point P. So we need to find the distance of the building from the point P. Pretty easy. Let's try this out. So we know the height of the building is 10 meters. We are supposed to find AP and we are supposed to find DB. This forms two triangles. One is triangle PAB and another is triangle PAD. So let us first deal with the triangle PAB. So we will take triangle PAB. This is 90 degrees. Now in triangle PAB, we know the angle which is 30 degrees. We know the opposite side which is 10. We need to find out the adjacent side AP. So opposite over adjacent, which ratio? Tan. What is the angle of elevation for PAB? 30 degrees. So tan 30 degrees is equal to opposite, which is AB, that happens to be 10, divided by adjacent AP. Tan 30 is how much? 1 over root 3. So 1 over root 3, by now you need to know these trigonometric ratios, equal to 10 over AP. So cross multiplying, AP is going to be 10 times root 3, that happens to be 17.32 meters. So now we know what's AP, 17.32 meters. So that is the distance of the point from the foot of the building. We need to now figure out the distance DB, if this is X. We can consider the triangle PAD now, and let's see how to work it out. Now we need to figure out the distance DB, the height of the flag staff. So let us consider the triangle PAD. So we are now looking at triangle PAD. Now in triangle PAD, what is the angle of elevation? 45 degrees. Now from the 45 degree angle, AD happens to be the opposite side and AP is the adjacent side. Okay, so opposite over adjacent, which ratio? Tan again. So tan 45 degrees is equal to opposite side is AD, complete, divided by the adjacent side, which is AP. What is the value of tan 45? It's 1. Good. 1 equal to AD is nothing but AB plus BD. So that is 10 plus X divided by AP is 10 root 3. We looked at that. We got the decimal of that. But we will not deal with the decimal. Let's deal with 10 root 3. So cross multiply. 10 root 3 is equal to 10 plus X. 10 root 3 minus 10 equal to X. So X is going to be equal to 10. Taking the 10 as a common factor out, root 3 minus 1. Simplify it, you get 7.32. So the height of the flag is 7.32 meters. So we can just mark it here. This height is 7.32 meters. Great, we found out the height of the flag. We also found out the distance of the point P from the foot of the building. In both these cases, we used tan. Great. Let's try another problem. Let's try this. The shadow of a tower standing on a level ground is found to be 40 meters long when the sun's altitude is 30 degrees. Then when it is 60 degrees. Find the height of the tower. So let the height of the tower be h. AB is the tower. And let BC be x. And when the altitude of the sun is 30 degrees, the length of the shadow is dB, that is 40 plus x, because it's 40 meters longer. So there are two triangles now, triangle ABC and triangle ABD. So let's consider triangle ABC now. In triangle ABC, the angle of elevation is 60 degrees. The side opposite to 60 is h, and this is adjacent side. So opposite over adjacent, which ratio? Tan. So tan 60 is equal to opposite, which is h, over adjacent, which is x. What is tan 60? It is root 3. So root 3 is equal to h over x. Let's label this as equation 1. Now let's come to triangle ABD. Triangle ABD. Now in triangle ABD, we have the angle of elevation as 30 degrees. The opposite side is h. The adjacent side is now 40 plus x. So opposite over adjacent, which ratio? Tan again. So tan 30 degrees is equal to opposite, which is h, over adjacent, which is 40 plus x, or x plus 40. What is the value of tan? Tan 30, it is 1 over root 3. So 1 over root 3 is equal to h over x plus 40. Now look here. H is equal to x times root 3 if I cross multiply. So instead of h over here, can I plug in as x root 3? I can. So this will become 1 over root 3 is equal to x root 3 over x plus 40. Cross multiply. So we get x root 3 times root 3 is equal to x plus 40. X root 3 times root 3 is 3x equal to x plus 40. Move the x on the other side, so you get 2x is equal to 40, x is equal to 20. So we know x now. Can we take the value of x and plug it into equation 1? Because we know that h is x root 3. So the height of the tower h now is going to be x root 3. X is 20 and root 3 meters. So the height of the tower is 20 root 3. A little bit lengthy calculation, but an easy one. So keep moving. Let's work out another problem. Let's try this. The angles of depression of the top and the bottom of an 8-meter tall building from the top of a multi-storied building are 30 degrees and 45 degrees respectively. Find the height of the multi-storied building and the distance between the two buildings. So we have a building AB over here. What is the height of this building? It's 8 meters. So let's lay 8 meters. Now this is a multi-storied building PC. From the top of the multi-story building to the top of this, the angle of depression is 30 degrees. From the multi-story building to the bottom of this building, the angle of depression is 45 degrees. So we need to find the height of the multi-story building, PD plus BC. Now if you observe, this line QP is parallel to BD and PB happens to be a transversal, and we studied in parallel lines, when they are cut by a transversal, alternate interior angles are equal. So this 30 degrees will be equal to this angle over here, which is 30 degrees. Similarly, this angle 45 degrees will be equal to this angle 45 degrees over here. So let's mark that out. This is going to be 30 and this is going to be 45 degrees. So now we have two triangles, PDB and PCA. So let's deal with the triangle PDB. Now if we take tan 30 degrees is going to be equal to the opposite side, which is PD, over the adjacent side, which is BD. Now what is tan 30? It's 1 over root 3. So 1 over root 3 is going to be equal to PD over BD, which implies that PD is equal to, or BD is equal to, BD is equal to PD times root 3. So we have one part of it. Let's keep it aside. Now let's come to the triangle PAC or PCA, whatever. So if we come to the triangle PCA, tan 45 degrees is going to be equal to the opposite side, which is PC, over adjacent side, which is AC. What is tan 45? It is 1. So 1 is equal to PC over AC, which implies PC is equal to AC. Now if you observe over here, AC is same as BD and AB will be same as DC. AB is already 8, so DC will also be 8. Okay, let's write down what we have found so far so that we get a perspective of the problem. So BD we found out to be equal to PD times root 3. Then we also found out from the triangle PCA, PC is equal to AC. Now PC, the complete multi-story building, PC is equal to PD plus DC. And we know DC is 8 because AB is 8. So PC is equal to PD plus 8. But if you observe over here, we found out that PC is equal to AC. So instead of this PC, can I write AC? Of course I can. So AC will be equal to PD plus 8. But again, observe AC is equal to BD. So instead of this AC, can I write BD? I can. So BD equal to PD plus 8. But we found out that BD is equal to PD root 3. So instead of this BD, can I write PD root 3? I can. So PD root 3 is equal to PD plus 8. Now it becomes pretty simple to simplify. Move the PD on one side. So we have PD root 3 minus PD is equal to 8. Take PD common out. So we are left with root 3 minus 1 equal to 8. So from here, PD will be equal to 8 over root 3 minus 1. Now we have learned how to solve such type of problems. Rationalizing the denominator. Remember that in grade 9? So 8 over root 3 minus 1. How will you rationalize? Multiply and divide by the conjugate of the denominator, which is going to be root 3 plus 1, root 3 plus 1. And when you simplify all this, which you have already done many times in grade 9, the result you will get is 4 times root 3 plus 1. So PD is 4 times root 3 plus 1. That's your PD. But the height of the total multi-story building, PC, is going to be 4 times root 3 plus 1 plus 8. So PC is going to be 4 times root 3 plus 1 plus 8. So that is going to be the multi-story building, the height of that. If you open the bracket and simplify, that's going to be 4 times 3 plus root 3 meters, the height of the multi-story building. What will be the distance AC? Can you guess? The question asks for the distance between the two buildings. What will be this distance AC? AC is equal to PC. So therefore AC will also be 4 times 3 plus root 3. So this will also be equal to AC. So we found out the height of the multi-story building PC. We also found out the distance between the two buildings AC. So wonderful. Let's try another one. Let's try this. From a point on a bridge across a river, the angles of depression of the banks on opposite sides of the river are 30 degrees and 45 degrees respectively. If the bridge is at a height of 3 meters from the banks, find the width of the river. So we are interested in finding the length AB, which is nothing but AD plus DB. The angle of depression is given as 30 degrees and 45 degrees. The height of the bridge from the river is 3 meters. So this forms two triangles, PDA and PDB. So now this is the horizontal line. This happens to be a transversal. If this is 30 degrees, can you guess what is this angle going to be? 30 degrees, alternate interior angles. So let's mark them on the figure over here. So this is also going to be 30. If this is 40, this is going to be 45 degrees. So now let's deal with the triangle P. This is P. PDA. Tan 30 degrees is going to be opposite, which is BD, over adjacent AD. Tan 30 is 1 over root 3 equal to PD is 3 meters over AD. So AD is 3 root 3. Good. Now let's try coming to triangle PDB. Tan 45 degrees is going to be equal to opposite, which is PD, over adjacent, which is DB. Tan 45 is 1. PD over DB. Therefore, PD is going to be equal to DB. So, the length AB is equal to AD plus DB. And AD is 3 root 3 plus BD is equal to PD, which is 3. So take the common factor out, root 3 plus 1. So the width of the river is 3 times root 3 plus 1 meters, Very good. This completes the lesson on application of trigonometric problems. Great going. Keep practicing. You can take up more problems in practice and continue watching the videos for the lessons. Please share and subscribe to this channel, Wisdom Outlined. Thank you.